Hello, this is mathjazz from Almost Cool. This is the third video in our series of trigonometry review videos. Our topic today is trigonometric identities. The first identity we're going to talk about is the Pythagorean identity. This identity is a consequence of the Pythagorean theorem. It's one of the few identities that you should memorize. I say few identities because even though there are many trigonometric identities, almost all of them are just different ways of rewriting three of them. Those three being the Pythagorean identities and the angle sum identities, which we'll get to a little later in the video. The Pythagorean theorem says that the sum of the squares of the two short sides of a right triangle equal the square of the long side of the triangle. Since we already defined sine and cosine to be the x and y coordinates of a point on the unit circle that makes an angle theta with the positive x-axis, that means that on this triangle in the diagram, the vertical side of this triangle is equal to sine of theta, and the horizontal side is equal to cosine of theta. So, therefore, cosine squared theta plus sine squared theta equals the square of the hypotenuse. But the unit circle is the circle centered at the origin with a radius of 1, so that means cosine squared plus sine squared equals 1 squared, but 1 squared is 1, so that gives us the Pythagorean identity. Sine squared x plus cosine squared x equals 1. Now, as I said, there are many trigonometric identities, and they mostly come down to rewriting the three we're going to learn, or combining the three that we're going to learn in this video in various ways. Here I give what I'm going to call Pythagorean-esque identities. These are identities that come purely from the Pythagorean identity. We're just rewriting them. For example, the first one I have here, 1 plus cotangent squared x equals cosecant squared x, is obtained from the Pythagorean identity if we divide every term in the Pythagorean identity by sine squared of x. The second one is obtained by dividing the Pythagorean identity by cosine squared of x, and the third one is obtained by solving for cosine of x. So these identities will usually end up somewhere in a reference guide. If you have a calculus textbook, these will probably be on the inside of the front cover or in an appendix at the back of the book or something. But really, you don't need to memorize these if you have the Pythagorean identity memorized and are able to manipulate it comfortably. Then basically, instead of memorizing 4 identities, you can memorize 1 and just transform it into whichever identity you need at the time. Here are the other two identities we're going to learn. They're called the angle sum identities. We have an angle sum identity for sine and an angle sum identity for cosine. They go sine of x plus y equals sine of x times cosine of y plus sine of y times cosine of x. Cosine of x plus y equals cosine of x times cosine of y minus sine of x sine of y. Those are our two angle sum identities, and you should memorize them. We also have angle difference identities, and these are, instead of sine of x plus y, it's sine of x minus y, and that'll equal sine of x cosine of y minus sine of y cosine of x. We do not need to memorize the angle difference identities, but I'm using these as an example of how the angle sum identities can be transformed into other identities. We probably don't need to memorize these, although for some people it's easier for them to memorize than for other people, and for some people it's harder to convert trig identities into other trig identities. For me, it's way more costly to focus on memorizing something than it is to just derive it from scratch. So for me, I remember 3 identities. You might choose to remember 5 if you want to include these angle difference identities, but I don't. That's up to you. However, you should see at least how to derive the angle difference identities from the angle sum identities. It's good practice, and it'll help you feel more comfortable in deriving identities from other identities. So we're going to find the angle difference identity for sine, and key to this is we're going to remember that sine is an odd function and cosine is an even function. The first thing that we do is we realize that sine of x minus y is the same as sine of x plus negative y, and then we use the angle sum identity, so we get equals sine of x cosine of negative y plus sine of negative y cosine of x. From here, since cosine is an even function, cosine of y equals cosine of negative y, so we can just swap this cosine of negative y for cosine of y. And since sine is an odd function, sine of negative y equals negative sine of y. So we can swap this positive sine of negative y for a negative sine of positive y. Now we do that. And notice now we have the angle difference identity for sine. The proof that, or the derivation, I should say, of the cosine angle difference identity is done in exactly the same way as the sine identity, and so I'll leave that to you for an exercise. Thank you for watching this email. My contact information and the contact information for Almost Cool are on the screen. They're also in the description below the video. Feel free to email suggestions, comments, concerns, criticisms, or just anything else you want to send to any of these locations. Also, if you find any errors, please inform me, and I will try to fix them on the video. I love making these videos, and I hope that you're enjoying learning calculus, or in this case, trigonometry from these videos. Hope you have a great day. See you. Bye.